Welcome to the course. Let's do one vertical question today. The question is, there is a vertical curve, and in that vertical curve there's a P, there's a R. This is the vertical curve, and there's a spot at Q, and they want to know what's the elevation at S. So first we have to get to the elevation at Q, and then we get to the elevation at S. That's what we are trying to do. So they have given us the radius of this curve, which is 250 feet. But since the P is in here, we actually have to get into this is they have given 40 feet. So we have to get uh, the length of that. So let's see. So this is the first thing. This is P. And then they also gave us the gradients. The gradient is 3.2 percentage. Here it's a negative 2%, and this is R, this is P. And the elevation at PVI is 130.25 feet. Also, now they are asking the elevation at S, which is, so if we take about the cross section of this road, it's actually going to look like this. If this is S, if this is Q, they say there's a 2% slope, and the 40 feet is what the distance is. So now let's get to the question. So first thing is we have to know the real radius. The real radius is actually 250 feet minus 40 feet over 2, because we need from inside. This is the length we want. So that's what we are trying to do. And this is actually 230 feet. That is easy, clear, easy thing. First thing. Second thing is we need to know the length of the PR of curve. PR length is, the equation for that for any curve is 2 pi r I over 360. Good news is we know the angles in here. We know the angle in here, which is 40 degrees. We know the angle in here, which is 60 degrees. So using that, so the total I means the angle, and this is 40 plus 60. 2 pi r is 230 feet. I is 100 degrees and over 360 degrees. This gives us 401 feet. Let's also get the length of PQ because we have to we will need that. PQ length is the same equation. Instead the 100 degrees we will use 40 degrees because PQ is at 40 degrees. So 2 pi r is 230 feet. I is 40 degrees, 360. This will give us 160 feet. Now we are getting to the elevation of BVI. So because the main equation, we have to know the elevation of the P. We have to know the elevation at P to get to the elevation at Q. So how do we do that? Because we already have the PVI elevation, we can get there by using BVC elevation is equal to elevation of PVI minus GL over 2. So that is actually 130.25 elevation, which is given. G, the gradient of this one is 3.2. And L we just found, which is 401, 100. I'm going to use 4.01 here because 3.2 we didn't use slope here. We didn't say percentage. So we don't have to use 401. Instead it's 4.01 feet. And then this number is, the elevation at BVC is 123.82 feet. Now we get to the last step, which is elevation of Q. R x squared 2 plus gx plus elevation BVC. In here the R is not the radius, it's the gradient difference. over L. Last gradient is 2%, but it's a negative. And then this is 3.2. Divided by L, which is we found 401. So what I do is, instead using percentages here, I will have sorry, like this, and then we will get our point number, which is 1.29 negative. X is the length from BVI to the spot. So from BVI spot to the Q, this length, that is what we found as PQ length. Here we found it, which is 160. So X is 160 feet. So let's put everything to the equation. Negative 1.29 R, X is 1.6 square over 2. G is 3.2 and X is 1.6. And then elevation of BVC, we found it here, 123.82. Plugging all these numbers, we will get 127.77 feet. And then we are reaching to the last step, which is fifth step, because we have, this is now what we got is the elevation at here. We got the elevation at Q. We want the elevation at S, and we know the slope is 2%. We know it's 40 feet. So it's 127.77 plus 0.02% into 40 feet. This will give us the final elevation, 128.57. I hope you understand. Thank you. We'll see you in the next video.